Okay, guys, let's go over this warm-up. I put some extra bits in the lesson today, and let's just go over these. So this was the warm-up. Evaluate this function here for f of 0, f3, f of 10, then draw these two graphs. I'll spend longer on the graphs probably. So f of 0, what they're telling you is you're being given the information that x equals 0, and you're being asked what the value of the function is when f is 0. Okay, so imagine x is 0. You're not trying to put it in all three pieces of this function. You have to find out first which piece is applicable. So if x was 0, let's replace x with 0. You have to look over here. Is it true that 0 is greater than 8? No, obviously not. So we're not using this piece. Does 0 lie between 3 and 8? No, so we're not interested in this piece. If we replace that x with 0, is 0 less than 3? Yes. So what we're doing here, our f of 0 will be f of x equals negative 4x plus 3 with a 0 in here. So what you're doing is you're finding your x value. That your x value tells you which piece you are on. You're not on all three, you're only on one of them. So these hints here written in green, you won't get those on a quiz, but you got them on a warm-up. So this one simply is, by using this piece here with a 0 in there, negative 4 times 0 plus 3 gives you 3. When f is 3, x is 3, imagine 3. Which x is 3? Not bigger than 8. Ooh, there or there. It can only be in one of them. Which of these intervals has x equal to 3? This one here. So we're putting in 3 there. Our function of 3 is going to be negative x cubed. It's going to be negative 3 cubed, so our answer is negative 27. And then with our function of 10. Now, for some reason, this one confuses some people. Let me get, I wish I could hide that. It's in my way. If x was 10, we're clearly not there. We're clearly not there. We're clearly here. But some students then get really confused because they want to replace an x with 10. There is no placeholder for x here. You're not substituting the 10 in anywhere. F of x equals 9, just 9. Not 9 times 10 or 9 plus 10 or anything. There's no placeholder for the x. Your function of x will equal 9 for any x value bigger than 8. So for x is 9, 10, 11, 42, 591, your function is going to equal 9. Okay? Now let's have a look at these graphs. And I hope you completed your attendance survey today. If you enjoy them and want to see the results and you're not in the KVA period, if you're in period 1, 2, and 6, they're available to you. I'm just not using them for attendance purposes. But for periods 3, 4, and 5, you have to do it. I'm sorry if you don't like them. Okay, you have to do them, and that's your attendance. So let's have a look at these graphs. So graphing by transformations is so much quicker once you get it than trying to graph by building a table of points. Now, building a table of points has worked for you fine, probably, up until this point. But when we reach trig, it really isn't going to. You're going to need to graph by transformations. So please, on a warm-up like this, try it. Better to get it wrong when you're trying in class than to stick with something that you know is limiting you and is going to stop you being able to move on in math. So how you graph for transformations. Once you know what you're doing, it's really quick and really simple. The first thing, you wouldn't do all of what I'm going to do now. I'm teaching you again how to do it. You recognize the parent function. So for this one, our parent function is y equals the square root of x. Now, that is not supposed to be on your answer. That's not what the question's asking for. If you need to graph it because it helps you think and reminds you what the parent function looks like, that's fine, but please graph it very faintly so it's almost not showing. You can't take the square root of anything negative and get a real answer, so we're not going to do any x values that are negative. So the smallest x value we're going to start with is 0. X is 0, square root of 0 is 0. X is 1, square root of 1 is 1. X is 2, I don't know the square root of 2. What's the next value I do know the square root of? It's 4. Square root of 4 is 2. Let me move this stuff out of the way. We'll talk about that in a minute. And the next value I'd know would be the square root of 9 is 3. So if I wanted to draw in the parent function, it would look like that. I don't really want the parent function though. I want to graph by transformations. Now you can do either graph by transformations by doing, for this one I could do 3, 4 different graphs, or I can do it in one step. I'll talk you through how you do it in different steps, and then I'll show you how to do it in one step. So if you're doing it in separate steps, well, for both ways, first of all, oops, missed a bit, you have to identify what your transformations are. This is outside the function, so it's going to be a reflection over the x-axis. It'll reflect anything going up to reflecting down. Bring this point will be reflected down here. This point here will be reflected down there. This is going to move the whole graph to the right to, remember if it's inside it goes the wrong way. That's going to move it all right to, move that out of the way. And this is going to move it all up 1. So you can do this in steps. You can draw the parent function. So we would actually, if you're doing it in steps, you draw the parent function. Then you reflect it over x. So that would give you this point here, this point here, this point here. Then you shift it all right 3, then you shift it all up 1. Now I can do that easily on a smartboard and move it right 3, up 1. That's my final answer. But that would have required you drawing 1, 2, 3, 4 different graphs maybe. It's a lot of work. There's a much easier way. You can do it in one step if you know your parent function well. What you do is you actually do what everyone tells you mustn't do. You do your shift first. But what you do is you shift what is happening at the origin. So you shift your reference point and give yourself a new origin. So we shift that right 2, up 1, and that's like a new origin. Then you graph all these other points you would normally graph, applying any reflections, compressions, and stretches to them. Now, how you graph them is you consider this. On our parent function, from the reference point, we then had the point 1, 1. But if you're graphing by transformations, you don't think of it as the point 1, 1. You think, how do I get there from this reference point? Well, you go 1 to the right and 1 up. How do I get to this point? I don't think of it as 4, 2. I think of it as go 4 to the right and go 2 up from the reference point. 4 to the right, 2 up, and this one here would be 9 to the right, 3 up. So you think of these in words. If you had any stretching, say you had a vertical stretch of 2, you would change this 1, you'd multiply it by 2. If you were stretching by 3, you'd multiply that by 3, and you'd multiply this by 3. So you multiply your x and y coordinates by any stretches or compressions, and you apply your flips. When you reflect things, if I'm reflecting over the x-axis, when I was going up, instead I'm going to go down. So to do this in one step, I think of getting from the reference point to this point here. It's normally 1 right, 1 up. Because I'm reflecting over the x-axis, when I see the word up, I think, no, I'm going to go down instead. Okay? So normally the first point I plot after the reference point. From the reference point, I go 1 right, 1 right. I'm not going 1 up, I'm going 1 down. Then this point. From the reference point, I go 4 to the right, and I'm not going 2 up, I'm going 2 down. And there's my graph. And it gets so quick when you're used to doing it. Now let's remove the bits that we wouldn't want to have on our actual answer. We wouldn't want that. And obviously we don't want all this junk all around there. And we don't want this, and we don't want that. Yeah. So let's look at the next one. If you want to pause your video and try it on your own, then I'll go over it. So on this one, we try to trick you. Remember that you shouldn't have anything in front of the x inside a function, inside the parent function part. Shouldn't have anything in front of the x except for maybe the beginning of the parent function or a parentheses. So this minus must be factored out, or my horizontal shift will be wrong. So if this is factored out, this will turn into plus 2. I cannot factor the negative out from this. This is not anywhere close to those parts. This is outside the square root. You can't start factoring things that are inside and outside at the same time. It's just bad math. So we're going to factor the negative out of just this part, everything under the square root. Okay? Now write down your transformations. This time our reflection, it's inside the parent function. So this one's going to give us a reflection over the y-axis. When we come to do our transformations, reflection over the y-axis, if you had a point over here, it would reflect over there. So it's changing the word right to be the word left. And that would change to left as well. Okay, so that's what's going to happen when I use transformations. That's going to make the word right turn into the word left. And if I had the word left, it would turn into the word right. It's not going to affect up or down because we're only going with the y-axis on that. And then this part is going to take me left 2. Remember, they go the wrong way if they're inside. And that one's going to take me up 1. So let's do exactly what we did last time. Let's shift what was happening at the origin. On the parent function, it starts at 0, 0. We're going to go left 2, up 1. So that is like my new origin. That's my new, where the reference point is. Now I just plot the equivalent of these points. So if going 1 right and 1 up, I'm going to go 1 left and 1 up. Instead of going 4 right and 2 up, I'm going to go 4 left from the reference point. 1, 2, 3, 4, and 2 up. If I wanted another point, I would go 9 left and 3 up. It'd be up there. So that's getting you your curve. It looks like that. Okay. So that was the warm-up for today. We then had the lesson video was this, and this is on the page that I put in modules yesterday. So there's a video to take you through all of this. Okay, there was a video to take you through this. Then if you were with us in class today, we did this as a closing task. So if you want to try this, graphing, I think, is the most important part. Try graphing it, and then try evaluating it. Now, evaluate it 2 ways. Do it with algebra. You're more likely to get the right answers, like we did with the warm-up. Use algebra, and then use those answers to check your graph. I'll give you one explanation, show you how that works. Let's do this one. This is telling us this is asking us, when x is negative 2, what is my function value? What's my y value? So we look at negative 2 and we see which interval we're in. Negative 2 is not bigger than 3. Negative 2 is not between 1 and 3. Negative 2, yes, it is between negative 3 and 1. So I'm on this definition here, and I'm going to replace that x there with negative 2. Okay, so my function of negative 2 is going to be negative the square root of negative 2 plus 3. So here's one I prepared earlier, I hope. No, it's not there. Okay, right, never mind. It would be negative the square root of negative 2 plus 3, which equals negative the square root of negative 2 plus 3 is 1, which is negative the square root of 1 is 1. So that's my answer. Now, that's the answer to that question. How could I use that answer to help me check my graph? If you'd already done your graph, you'd be able to check it now. Because what this is telling you is when x is negative 2, your function or your y value equals negative 1. So it's telling you the point negative 2, negative 1 should be on your graph. And if it isn't, you did your graph wrong. Okay? So if you haven't already, pause your video and attempt that graph, and I'll go over it for you in a second. Okay, so starting up your graphing. Let's graph this piece first. Let's pretend it's 3 different functions and talk about them. So this is your square root function reflected over, so it's your square root function, reflected down, and then move left 3. Okay, so I'm shifting the reference point there. Then to draw my points, I'm reflecting what should have been going up is going to go down. So instead of getting this point here by going one right, one up, I'm going to go one right, one down. Ooh, look, that's going to fix with what we just said there. Then the next point would be, normally I go 4 to the right, 2 up. Because of this reflection, I'm going down instead of up. I go 4 to the right and 2 down. And my next point would be 9 to the right of my reference point. 1, 2, 3, 4, 5, 6, 7, 8, 9, down, and the square root of 9 is 3. So instead of going up 3, I'm going down 3. So that would be, if I drew it in, the full function of y equals negative x plus 3. But how much of it do I want? Don't ignore these bits. This is super important. This is telling me I'm only going to graph that from negative 3 included, so from x is negative 3 included to x is 1 included. So I'm going to start with a solid blob when x is negative 3, which is actually, oh, that was my reference point. And I'm going to finish when x is 1. So x is 1 here. Oh, that's that point there. Solid. So there's my graph. And I don't need that bit. So if you'd drawn the whole function in, you would erase all of that to that point. Let's look at your next bit. Looking at this, if you were in Algebra 1, oh, I don't want to do it in green, let's do it in blue. If you're in Algebra 1 and you were asked to plot y equals 2x minus 2, I hope you remember this is what we call slope-intercept form. This is giving you your slope, your rise over run. This is giving you your x, your y-intercept. So how you graphed that in Algebra 1 was you started at the y-intercept and then you plotted your slope, but going up, rising up 2 across 1, rising up 2 across 1. So let's just dot in some points and decide which ones we need. So we start at the y-intercept, so that starts there. Then we plot the slope. Rise up, run across. We're rising 2 over 1, yeah? Rise up, 2, cross 1, 2, 1, 2, 1, 2, 1. Then you could go backwards, 2, 1, 2, 1. And that would be a straight line, a linear function. But we're on a piecewise function. We don't want that whole line, and it's better to just not even draw it all in. Look here. What is this telling us? It's saying we're going to start that line with x is 1. We are starting with x is 1, but it's not included. This doesn't mean start with x is 2. It does mean start with x is 1, but make it an open circle because it's excluded. And finish when x is 3 as a solid blob. So let's go to where x is 1, and oh, look, we're on that point there. Excluded. No equals part there. Then we find when x is 3. So this point here, make it a solid blob, and all we want is that part of the line there. We don't want the rest. So I don't need those blobs. They're only dots. You could have probably left them. They weren't very obvious. And then your last part of the piecewise function is this one. If you're plotting y equals 1, if you plotted the whole thing, that's a horizontal line going through y is 1. But that's wrong, isn't it? Because, let's look over here, let's get all that junk out of the way. This here is telling us we just want x values that are bigger than 3. That doesn't mean start at 4. It means do start at x equals 3, but just exclude that initial point. So we're going to start at x equals 3, excluded, and we're going to keep all the bigger values of x. We're going to keep that part of the line. And this stuff, I should probably never have drawn it in the first place. So that is my graph of this piecewise function. Just take a second to check your graph is right. It's one function, so it better pass the vertical line test. Get your pencil, hold it like a vertical line, scan it across the graph. crossing in one place, one place, one place. Oh, that looks a bit dodgy, but hold on, that one's complete and that one's open. We're fine. Crossing in two places again, but we're fine because that one's included, that one's excluded. Everywhere. If for instance, if this square root, if I'd extended it or drawn it in the wrong place and drawn it there, you'd know you'd be failing because you'd be crossing two parts of the line. Okay, now let's look at these final evaluate ones. So that's the graph drawn nicely. Evaluating -2 when x is -2, we're using this part because that's where x is -2 fits, doesn't fit there or there. We get that. When x is 1, no, not there. That one's excluding 1. This one's including 1. We're here again. So we're going to have -1 plus 3, square root of 1 plus 3. So negative the square root of 4. Square root of 4 is 2. So we've got -2. Now, just use this to check our graph. Is the point when x is 1 and y is -2 on our graph? X is 1. Yes, it is. It's there. That's good. Okay, now let's have a look at this bit. Function of 0. Oh my goodness, we're still in this one. We haven't moved to the other ones yet. So 0 plus 3 is 3. My answer is minus the square root of 3. Ew. Do you know what the square root of 3 is? Well, you know what the square root of 4 is. You know the square root of 4 is 2. And you know the square root of 1 is 1. So this must be a number somewhere between 1 and 2. So when x is 0, my y should be negative a number somewhere between 1 and 2. And look, it is. That would be this point right there. That's good. And our last one, function of 3. When f is 3, we're on this one. Okay, when x is 3, so we'd have 2 times 3, which is 6. Take away 2 is 4. So use that now to check your graph. That's your answer to this question. Your answer here is 4. Like that was your answer to the previous question. What I'm also getting you to do is to use that answer to check your graph. So a quick check on your graph. When x is 3, does y equal 4? Let's look on our graph. When x is 3, y is 4. Yay! My graph's good. Okay, I hope you found that helpful. Let me see if I can work out how to stop my video.